Hey there, Algebra 2 students. I hope that you are well. Today I wanted to talk to you about 9.6 a little bit. So there are a couple points before we dig into some example problems. The frequency, anytime you see frequency, frequency is equal to the reciprocal of the period. All right. And I want you to remember the general formula that we've talked about when graphing sines and cosines or sinusoidal graphs. Y equals A times the sine of B times x minus h plus k, where h is your horizontal shift, k is your vertical shift, A is the amplitude, and B is related to the period of the function. So let's take a look at this example here. An alternating current generator, an AC generator, converts motion to electricity by generating sinusoidal voltage. Assuming that there is no vertical offset and phase shift, meaning H and K are 0, right? The voltage oscillates between negative 170 volts and positive 170 volts with a frequency of 60 hertz. Write and graph a sine model that gives the voltage V as a function of the time t in seconds. Okay, I did not draw a graph, and I'm not going to today. The amplitude is, since it goes between negative 170 and positive 170, our amplitude is 170. All right. They tell us that the frequency is 60 hertz, so the period is the reciprocal of that. So 1 over 60, and 1 over 60 is equal to 2 pi over b, right? That's how we find that. 2 pi over b is equal to the period. And so I cross-multiplied to solve for b. b is 120 pi. So I'm going to plug the 170 and the 120 pi into my equation up above. So I get y equals 170 times the sine of 120 pi t, because we need to use the variable t for time in seconds. Okay. We're going to do a couple other problems here. Let's see. In exercise 2, we've got various points here. When we are looking at these graphs, I want to, and I'm trying to find an equation, I'm going to write down the basic form of this equation, right? And then I'm going to step through the different pieces. Okay, amplitude, how high does it go up? How low does it go? It goes up to 2, down to negative 2. That means my amplitude is 2, right? Okay, then I need to figure out what on earth is the period of this function, right? I can see that there's a maximum at pi over 6, there's a minimum at pi over 2, but the rest of the points aren't really labeled for me. So I did pi over 2 minus pi over 6. That's going to be half of the period, right? So I multiplied the pi over 2 by 3 over 3, and when I subtract, I get 2 pi over 6, or pi over 3. Remember, that's only half of the period, so I multiply that by 2. I get 2 pi over 3 is the period. Now remember that b is 2 pi over b. The period is 2 pi over b. And if the period is 2 pi over 3, then b is equal to 3. Okay, then I want to look for a vertical shift and a horizontal shift. Our center line is still 0, so k is 0. There's no vertical shift here. And then I look for a horizontal shift. If this is a sine function, is it passing through the origin going up or not? And it is. It's passing through the origin going up, and so it looks like there is no horizontal shift. And so I would say that h is 0 here. And so this equation would be y equals 2 times the sine of 3x, because b is 3 and a is 2. Y equals 2 sine of 3x. Let's take a look at this guy here. There's a little typo. That should be a positive 0.5. So we can see that it's going up to 0.5, down to negative 0.5. So that tells us our amplitude is 0.5, or 1/2, right? Then we look for the period. How far between either valley to valley or peak to peak? I went with valley to valley because I see a valley, well, a minimum, right, at 0, and I see another minimum at 2, so that means that the period is 2. But I need to figure out what b is in order to write an equation. So remember that the period is equal to 2 pi over b, and so we set up this equation and we solve for b, so b is pi. Then I'm looking for, is this a cosine function? Is this a sine function? Which is it, and what's my horizontal shift? There's a couple ways that you can do this, right? I think it's easiest to consider this a cosine function that's been shifted to the right 1 unit, right? Cosine usually has a peak when x is 0, and so this has just been shifted to the right 1 unit, and so we would have an x minus 1 there. We figured that b is pi. We know that the amplitude is 1/2, and there is no vertical shift, right? It goes through your middle center line, sort of goes through the x-axis. Okay. Let's try one more problem. I don't know if you can see it. Again, this is in your student journal. This does have a vertical shift, right? You can see that the center line is halfway between the 5 and 1, which is actually at 3. So I sort of sketched that in and immediately wrote, hey, k is equal to 3. All right, so then I want to say, well, what's the amplitude? How high above the 3 and below the 3, how far does it go, right? The amplitude, it's going 2 units above, 2 units below, so the amplitude is 2. Okay, well, what about the period of the function? How far is it between peaks and valleys? So I looked at the valleys, right? There's a valley here at 1, 1, and at 5, 1. So the difference between the 5 and the 1 is 4. So the period is 4, but we need to figure out what b is. So 2 pi over b is equal to 4. And then I need to solve, right? So I multiplied both sides by b, divided both sides by 4. I get b is pi over 2. Okay, all right, so I've got k, I've got a, I've got b. Is there a horizontal shift? Maybe. It depends on how you look at this. Okay, I have 2 solutions written for this equation. I looked for the sign going up sort of through the origin and said, you know what, this has been shifted to the right 2 units. So my initial answer was y equals 2 for the amplitude times the sine of pi over 2, right? That's b, times the x minus 2, that's my horizontal shift, plus 3, that's my vertical shift. When I checked with the answers, though, the answers said y equals negative 2 times the sine of pi over 2 times x plus 3. What's the difference here? This one has a negative sign in front. This has a minus 2 over here. Here there's no horizontal shift. When I type both of these into my calculator, they produce the same graph. So there are 2 equations that model the same graph. And you will find that to be the case with all of these functions. There's more than one answer. And so it makes things a little interesting and a little exciting. I think that's all for today. I hope this helps or maybe confuses things more. Be sure to ask your questions and let me know what makes sense and what doesn't. I hope that you're all well. We'll see you next time.